Here we're going to graph y equals 1/2 times the cosecant of theta plus 2 pi over 3. What we're going to do first, remember, is we're actually going to graph the reciprocal function, which the reciprocal of cosecant is sine. So we'll graph 1/2 sine of theta plus 2 pi over 3. And once we do that, we can use that graph to help us with the cosecant function. So as we go through this, we're going to go through all the same things that we have done with all the other sine functions. So we'll have a phase shift. We will have period, amplitude, and vertical shift. So the phase shift is what is added to theta. Well, here 2 pi over 3 is added to theta, and it's the opposite of that. So the phase shift is going to be left 2 pi over 3, which is going to bring us to negative 2 pi over 3. So we're going to put that as our starting point. That's our starting point. So we're at 2 pi, negative 2 pi over 3. Notice I haven't put the x-axis on here, so I'm going to put negative 2/3 pi. And that's our starting point. Next, we go to the period. The period is 2 pi divided by whatever's multiplied by theta. Well, nothing special is multiplied by theta out here, so the period is 2 pi over 1, which is just 2 pi. So then we're going to find our ending point. Remember, to find the ending point, we take our starting point and add the period. Starting point plus period gives us the ending point. That's ending point means the end of our first cycle. So the starting point was negative 2 pi, 2/3 pi, plus our period of 2 pi will give us our ending point. Well, we need to get a common denominator. So we multiply by 3 over 3. And so really this is negative 2/3 pi plus 6 pi over 3 is going to give us our ending point. Well, 6 minus 2 is 4. So 4 pi, or 4/3 pi. So we're just going to give ourselves a decent amount of room. We're going to put 4/3 pi out here, our ending point. And then we're going to split that in half. So we're going to do our quarters here. I'm glad we're doing this one. This is where the quarters can get a little bit tricky, but what we do to find those quarters, we want to find the quarter of our period. So we take our period, which is 2 pi. We take a quarter of it, which is 2/4 pi, which obviously is 1/2 pi. And we're going to take that and we're going to add that to each thing here. So we're going to add 1/2 pi. We'll get that, add 1/2 pi again. So might take a little bit of room here, but we got negative 2/3 pi plus 1/2 pi. Well, we need a common denominator of 6. And so this is, we'll multiply the first part by 2. So we get negative 4/6 pi plus 3/6 pi gives us a negative 1/6 pi. So we got negative 1/6 pi. And then we're going to add this again, but I am going to realize that this is 3/6 pi, just getting the common denominator there. So add 3/6 pi. Gives us 2 pi over 6, which reduces to pi over 3, or 1/3 pi. So this is 1/3 pi, We're going to add 3/6 again, or 1/2 again. So we have 1/3 pi plus 1/2 pi. Common denominator, this is going to be 2/6 pi plus 3/6 pi is 5/6 pi. And then we're going to add 1/2 pi again, because we keep adding this quarter of our period. So we'll take 5 pi over 6. Now we actually don't have to do this one because we have the endpoint, but it's a good check. So we'll add the 1/2 pi, but remember 1/2 is 3/6. So 3/6 pi gives us 8/6 pi, which does reduce to that 4/3 pi. So there are the 4 quarters. What we can do now is we actually can kind of estimate where the y-axis is. We have a negative 1/6 and a positive 1/3. So it's going to be closer to the 6th. And so there is the y-axis. All right, that was a chore. So we went left 2 pi over 3. We have our period of 2 pi. We found our 4 specific points. And now what we're going to do is we're going to talk about amplitude. The amplitude is what's multiplied. Actually, we're doing the sine one, so we want to look at this. The 1/2. So our graph is just going to go up to 1/2. And down to negative 1/2. So a smaller amplitude. We can put our dashed lines there to show our guidelines there. So our amplitude was 1/2. And we graph after that. Remember, we're graphing sine. So we need to be at our starting place. So be careful not just to go to the y-axis. Here's our starting point here. We're starting on 0. After a quarter, we go up to 1/2. Halfway, we're down to 0, down to negative 1/2, and back up to 0. And if you want to, you can put a couple more points there. We made a pretty long x-axis. So there's a couple more points. And we can graph that sine function. Now we're graphing the sine function to aid us in graphing the cosecant function. And so remember, and by the way, there is none here. Nothing is added out here, so no vertical shift. We did all those things to help us graph cosecant. So we want to remember wherever there were zeros on the sine graph or x-intercepts, they're the same thing. We will have a vertical asymptote on the cosecant graph. So I'm going to draw in those vertical asymptotes. And then from there, we can graph the cosecant graph. We take our highest points, put a point there, and then we go towards the vertical asymptotes, the ones below the x-axis. We come down, and the purple part there is the cosecant graph.